A signal arrived from outside our solar system, not a radio signal, not a beam, a visitor. 3I Atlas crossed into our neighborhood quietly, moving faster than most things we track on a trajectory that does not belong to the sun. An interstellar object, rare, uninvited, and immediately interesting. We have instruments worth billions of dollars, space-based observatories, adaptive optics, precision tracking systems that can resolve terrain on Mars and storms on Jupiter. And yet, the clearest image of 3I Atlas did not come from NASA. It came from a backyard telescope. A single observer, Paul Craigs, pointing a modest instrument from Earth, produced an image of 3I Atlas with visible structure, texture, shape, something that looked less like a smudge and more like an object with geometry. NASA's publicly released images of 3I Atlas, by contrast, appear smooth, flattened, almost intentionally uninformative. That contrast is where the real question begins. If this were simply a matter of resolution or noise reduction, we wouldn't be talking about it. Differences in processing happen all the time. But when an interstellar object like 3I Atlas enters the frame, every decision becomes amplified. Every pixel carries weight. And when the sharpest publicly circulating image does not come from the most capable institution, curiosity follows naturally. I want to be precise here. Blurring does not mean deception. It does not mean hiding. There is no evidence that NASA has lied about 3I Atlas. Science does not work that way, but science communication does involve choice. What to emphasize, what to smooth, what to release, and in what form. Between raw scientific data and the images shown to the public, there is a long corridor of interpretation. Calibration, noise subtraction, contrast normalization, decisions that are routine until they're not. So the question is not whether NASA is concealing 3I Atlas. The better question is, how does NASA want the public to see 3I Atlas? Because images are not neutral. A clear image invites speculation. The human brain is exceptionally good at filling in gaps. Give it edges, shadows, asymmetries, and it will start asking questions that models are not yet ready to answer. A blurred image does the opposite. It dampens imagination. It keeps the object safely abstract. And 3I Atlas is not just any object. It is interstellar, is fast, does not yet fit cleanly into existing categories. We do not have a complete model for objects like 3I Atlas because we have barely seen any. Each one is, statistically speaking, an outlier, a data point too small to average away. In such situations, clarity can be dangerous, not because it reveals truth, but because it reveals uncertainty. I have watched this before. With Oumuamua, the first known interstellar visitor, the absence of clear imagery did not prevent speculation. It fueled it. Years of debate followed, not because we knew too much, but because we knew too little. And now 3I Atlas arrives in a different climate. Public trust in institutions is fragile. Discussions about UAPs are no longer confined to fringe forums. Congressional hearings have normalized the idea that unknown objects deserve serious attention. In that context, an unusually sharp image of 3I Atlas would not exist in a vacuum. It would collide with expectations, fears, narratives already in motion. So restraint becomes a strategy. Again, not concealment. Control of interpretation. But there is another layer here, one that makes the situation more interesting, because images are not just about what they show. They are about what they imply we can see. High-resolution tracking of a small, fast, distant object is not trivial. Demonstrating that capability publicly reveals something about observational limits, about response time, about sensitivity. Those are not purely scientific concerns. Sometimes making an object appear less defined is a way of keeping boundaries well defined. And then there is Paul Craigs. He did not accuse. He did not speculate wildly. He simply released what he saw, and in doing so he disrupted a balance that usually holds, the balance where interpretation flows one way, from institution to public. Now 3I Atlas exists in more than one visual form, and once that happens, a question starts to form, not loudly, not explicitly, but persistently. If an interstellar object can be seen in different ways, depending on who is looking, then what else might be encoded in that difference? Not an answer, a conclusion, just the sense that 3i Atlas is doing more than passing through, and that the most important signal may not be what it is, but how we are choosing to look at it. When we talk about blurring, it's tempting to imagine intention where there may only be process. That's why the word itself needs to be handled carefully. In science, blur is not a lie, it is a choice. And choices, especially repeated ones, tell us something about priorities. Every astronomical image you have ever seen is already an interpretation. Raw data does not look like a picture. It looks like noise, numbers, counts of photons mapped across sensors, corrected for bias, distortion, motion, and background interference. By the time an image reaches the public, it has passed through many hands, each one deciding what matters. With 3i Atlas, that journey matters more than usual. Because between what we measure and what we show, there is an invisible filter, narrative stability. Scientists are trained to tolerate ambiguity. The public is not. Ambiguity, when paired with something unfamiliar, tends to grow teeth. A crisp image of 3i Atlas would invite immediate questions. Why that shape? Why that asymmetry? Why that brightness gradient? And more importantly, why haven't we seen this before? The problem is not that these questions are unreasonable. The problem is that right now, science does not have equally crisp answers. 3i Atlas is interstellar. That alone places it outside the comfort zone of repetition. Our models of small bodies are built on populations that formed together, evolved together, and obeyed the same environmental constraints. 3i Atlas did none of that. It formed somewhere else, under unknown conditions, with a history we did not observe. When an object does not fit a model, the safest response is not to overinterpret it visually. This is not about hiding data. The data exists. Researchers around the world can request it, analyze it, test hypotheses, but the public-facing image plays a different role. It is not a tool for analysis, it is a trigger for meaning, and meaning spreads faster than peer review. A sharp image of 3i Atlas would not remain a scientific artifact for long. It would be isolated, cropped, enhanced, annotated, and recirculated. Edges would be traced, patterns proposed, comparisons made. The internet does not wait for error bars. From that perspective, a softened image functions as a buffer. It keeps the object in the category of interesting but unresolved. It delays narrative collapse into certainty, either mundane or extraordinary. And here's the subtle part. Once an image is released clearly, it cannot be taken back. The first interpretation tends to anchor all others. Even if later analysis contradicts it, the initial visual impression persists. This is a well-documented cognitive effect. We remember the first story we hear. With 3i Atlas, anchoring too early could be costly because the object is rare, because the data set is thin, because follow-up observations are limited by time, geometry, and distance. A misframed first impression could dominate discourse for years. We saw this with Oumuamua. Vague imagery did not prevent speculation, but it did prevent premature closure. The debate remained open precisely because the visual evidence never settled the matter. In that sense, the blur is not a wall, it is a pause that keeps the question alive. But there is a tension here, because while institutions may prefer ambiguity, individuals do not. Paul Craigs did not set out to destabilize anything. He simply pointed his telescope and shared what he saw. And what he saw added detail, not resolution in the technical sense, but enough structure to suggest that 3i Atlas is not just a dot, that it has form, that it may have features worth discussing. Once that happens, the public realizes something important, that there is more than one way to look at 3i Atlas. And when multiple views exist, the question shifts again. Not what is it? Not yet. But why are we being shown this version instead of that one? That question does not accuse. It does not conclude. It just waits. And waiting in science is often where the most interesting things begin. There is a lesson embedded in the history of interstellar objects, and it is not about what they are. It is about how quickly interpretation can outrun understanding. When Oumuamua passed through the inner solar system, we had never seen anything like it before. No tail, no obvious coma, acceleration without visible outgassing. Every one of those properties strained existing models. And because the images were indistinct, the debate migrated to theory, to physics, to assumptions. That debate never really ended. Years later, we still argue about Oumuamua, not because the data was hidden, but because the data was insufficient. And that insufficiency became fertile ground, not just for speculation, but for polarization. The object became symbolic. To some, it was clearly natural. To others, the absence of conventional explanations felt like an invitation to consider something else. NASA watched that happen, so when 3I Atlas entered the picture, the institutional memory was already there. A rare interstellar visitor does not arrive alone. It brings attention, expectation, and narrative momentum. And 3I Atlas arrived at a particularly delicate moment. Public conversations about unidentified aerial phenomena are no longer theoretical. They are official, recorded, debated in formal settings. The vocabulary of uncertainty has moved from late-night television into congressional transcripts. In that environment, releasing a high-clarity image of 3I Atlas would not simply inform, it would amplify, because clarity creates anchors. A clearly defined shape would immediately be compared to spacecraft, to debris, to structures we recognize. The comparison would not be fair, but it would be inevitable. Human perception is comparative by nature. We understand new things by mapping them onto old categories. The problem is that 3I Atlas does not belong to any category we know well. It is not from here. So any visual resemblance would be overinterpreted. A ridge becomes a panel, a shadow becomes a cavity, a brightness variation becomes intention, not because people are irrational, but because they are pattern-seeking. From an institutional standpoint, this is a known risk. An object that is poorly understood but visually striking can destabilize public confidence in scientific authority. Not because science is wrong, but because it appears unprepared. And unpreparedness, in the public eye, often reads as concealment. This is why restraint can look like caution. NASA does not need to fear 3I Atlas itself. Rocks do not threaten narratives. Interpretations do. What institutions tend to manage is not objects, but reactions. A blurred image of 3I Atlas keeps interpretation slow. It prevents the formation of a dominant visual myth. It buys time, time for more data, time for better models, time for context. But time is exactly what an interstellar object does not offer. 3. I-Atlas is moving fast. It will not linger. Observation windows are finite. Every delay is permanent, and that creates another tension between scientific patience and public urgency. Because while institutions slow down, individuals speed up. Paul Craigs did not wait for consensus. He did not wait for official framing. He released his image into an ecosystem that thrives on immediacy. And once that happened, the lesson from Oumuamua resurfaced in a new form, not as a question of origin, but as a question of control. Who gets to decide when an interpretation is premature? Who gets to decide what level of clarity is responsible? With 3I Atlas, those questions are no longer hypothetical. They are active. And there is one more layer to this, one that goes beyond communication and into the foundations of science itself. Our models rely on repetition, on families of objects, on statistical behavior. An interstellar visitor is the opposite of that. It is a sample size of one, an anomaly by definition. If 3I Atlas behaves in a way that does not align with known natural processes, then it does not just challenge explanation. It challenges expectation. It asks whether our categories are complete. A clear image could accelerate that challenge before the theoretical ground is ready. In that sense, the blur is not about hiding something extraordinary. It is about preventing something ordinary, our models, from being exposed too quickly as incomplete. And when a single object has the potential to do that, the safest move is often to let it remain, visually at least, unresolved, not because the truth is dangerous, But because the timing of truth matters, there is another dimension to this that rarely enters public discussion because it sits at the boundary between science and capability. Observing an object like 3I Atlas is not only a matter of curiosity, it is a demonstration of reach. To track something small, fast, and distant requires more than optics. It requires coordination, timing, algorithms that can predict motion across uncertainty, sensors that can discriminate signal from noise at the edge of detectability. These are scientific tools, but they are also strategic ones. When an image is released, it does more than show the object. It implicitly reveals what we can see, how well we can see it, and under what conditions. Every pixel is a clue, not just about 3I Atlas, but about the observer. High-resolution imagery of 3I Atlas would signal more than success. It would signal limits. Resolution implies range. Clarity implies sensitivity. And sensitivity implies thresholds that others can infer. Sometimes, ambiguity is a form of boundary setting. High-rise, for example, is often described as a scientific camera. That is true, but it is also proof of concept. It shows what is possible, publicly demonstrating its full capability on a fast-moving interstellar object would answer questions no one has formally asked, but many would quietly note. What is the smallest object that can be tracked? At what velocity? At what distance? These are not abstract curiosities. So a softened image of 3I Atlas serves a dual purpose. It keeps the focus on the object without advertising the observer. It maintains scientific interest while avoiding unnecessary disclosure of performance envelopes. This is not secrecy, it is prudence. And it aligns with a pattern seen across many advanced technologies. Capabilities are rarely displayed at their maximum, especially when there is no urgent need to do so. Demonstration is selective. In that light, the blur becomes less about 3I Atlas itself and more about context, about choosing not to turn an interstellar visitor into a calibration target for public inference. But once again, the presence of an independent image complicates that strategy. Paul Craig's did not reveal classified capability. His image does not threaten security, but it does remove the comfort of singular framing. It shows that clarity is possible, even if not identical in kind. And that contrast sharpens attention. When the public sees two versions of 3I Atlas, one precise, one restrained, they begin to intuit that images are curated, not discovered, that what we see is not the full picture, but a selected one. This realization does not produce panic, it produces awareness. And awareness shifts the conversation, not toward conspiracy, not toward certainty, but toward a quieter question. If restraint is intentional, what is it protecting? The object, the model, or the boundary between what we can observe and what we are ready to explain? 3I Atlas continues on its path, indifferent to these concerns. But the way we choose to present it reveals something about ourselves. Not what we know, but how much we are willing to show. Paul Craig's did not set out to challenge an institution. He did not frame his image as a rebuttal. He did not attach a theory or demand an explanation. He simply added another view of 3I Atlas to the conversation, and that was enough. Because science, at its core, depends on multiplicity. Multiple measurements, multiple perspectives, independent verification. When only one version of an object exists, interpretation feels settled. When a second version appears, even quietly, equilibrium shifts. Suddenly, 3I Atlas is no longer a single image. It is a comparison, and comparisons invite questions, not accusatory ones, not dramatic ones, the more unsettling kind, the kind that emerge slowly after the initial reaction fades, the kind that ask not what we are being told, but how. Paul Craig's did not answer anything about 3I Atlas. He did not tell us what it is. He did not suggest what it might be. What he did was simpler and more disruptive. He made it impossible to pretend that seeing is automatic. Once you realize that images are chosen, not inevitable, you begin to notice the space between data and display. You notice that knowledge does not arrive fully formed. It is curated, filtered, sequenced. This does not imply deception, it implies responsibility. Institutions manage uncertainty by pacing it, by deciding when clarity helps and when it harms. Individuals, on the other hand, respond to immediacy, to the instinct that more detail is always better. 3i Atlas sits exactly at the fault line between those impulses. It is unfamiliar enough to provoke imagination, sparse enough in data to resist closure, and fleeting enough that delay feels like loss. In that combination, every image becomes consequential. So we arrive at the real question, not whether NASA blurred 3i Atlas, not whether Paul Craig's revealed something hidden, not whether 3i Atlas is natural, artificial, or something we have not yet named. The deeper question is about agency. When an interstellar object enters our solar system, who decides how clearly it should be seen? Who decides when curiosity becomes destabilizing, when speculation becomes premature, when clarity becomes risk? These decisions are rarely debated openly because they usually happen quietly within familiar frameworks. But 3i Atlas is not familiar. It does not belong to our system, physically or conceptually, and that is why it matters. Because if the clearest image of an interstellar visitor does not come from the most powerful observer, it exposes something subtle. That authority in science is not just about capability, it is about narrative timing, what we are allowed to see, when we are allowed to see it, and in what form. 3i Atlas may turn out to be entirely ordinary, a rock shaped by processes we will eventually understand, or it may remain ambiguous, forever resisting simple classification. Either outcome is scientifically acceptable. What is not neutral is the process by which we arrive there. And as more objects like 3i Atlas inevitably pass through our neighborhood, this question will not disappear. It will sharpen. Because the next time it happens, the issue will not be whether we have better telescopes. It will be whether we are ready to look and to decide how much of the truth we are willing to let come into focus.